Yes, I know. We're still talking about that bloody Coriolis force. Anyway, it exists, and how can you visualize it? How can you know? How can I make you believe me? Okay, so what you need to do is you need to take. Maybe you can use your dad's old turntable. Okay, you have a turntable. You can actually produce rotation, and then you need a tank with fluid. Okay, what about your mom's aquarium? Okay, there's all the little fishies in there. Okay, don't worry. Put it onto the turntable and let it rotate. Place a camera on top, also rotating with the entire system. And what you also need is an underwater gun. Okay, you get yourself an underwater gun so that you can try to shoot at the fish. Okay, try to get one. Okay, and this is how you can simulate the Coriolis force on much shorter time scale. And I want to show you some animation which are shown here. So there are two simulations. On the left side is without rotation. So you switch off your turntable. You still have your gun there and your fishies. Fishies on the right. Gun is on the left here, and you look from above and just see whether I can start this simulation here. The bullet comes out, straight path. Oops. One fish less. Okay, I'm sorry about this. Okay, so now you start the rotation. Okay, the stuff is rotating. You can't see it in your movie because the camera also rotates with it. And let's see whether I can try to shoot a bullet. Okay, no, didn't work. Let's see whether I press the right button. Now it works. Okay, you can see, oh, it's a curved path. Missed the fish. All right, can I show it again? I try again. Okay, you can see curved path. This is the Coriolis force, because the curved path comes from the fact that it's like you try to walk a straight line and someone pulls at your shoulder and you go onto a curved path. So now the second part of this slide is, well, how can I understand that the Coriolis force changes sign between the northern and southern hemisphere, and that it disappears at the equator? For the Coriolis force to operate, you need a rotation. Okay, so for example, and this is shown here just next to my head, if you put a plane onto the North Pole and you let the Earth rotate, you can see that that this plane rotates. Okay. If you put the same plane onto the South Pole and you turn the Earth around, what you find is that the plane will actually rotate in the opposite direction. Okay, so now what you can do is, with your turntable experiment, is just reverse the direction of your turntable, and then you'll see that the bullet will fly the opposite way. Okay, and this explains the difference of the Coriolis force between the northern and the southern hemisphere. At the equator, so now you're at the equator, put a plane directly onto the equator, here shown in this little thing here, and let the Earth rotate. It moves around, but it never changes it never starts to rotate, never turns around like this. It always just moves around without any rotation. So at the equator, there is absolutely no Coriolis force. And please don't kill all your little fishies, okay? So don't do it.